Hey guys, section 6.4 is going to be all about matrix operations. So we're going to learn about adding, subtracting, and multiplying matrices. We'll also at the very end write a matrix equation that's equivalent to a system of matrices. This looks a little bit different than an augmented matrix, which we did in the last class. So first thing is just a couple of notational items. So if you're ever talking about a matrix, in general, you want to use a capital matrix or a capital letter to name your matrix. And then inside, if you're discussing certain cells of the matrix, you'll use lowercase letters. And you put two numbers on the lowercase letters. The first number describes the row you are in, and the second number describes the column you are in. So for example, if you saw A sub 2, 3, that would mean you are in row 2, column 3, and you would know exactly what entry to look at. A lot of times they'll use very general notation. So for example, in this one they have A sub ij. That just means this matrix has I rows and j columns, and they have not disclosed to you how many rows and columns that is. The first thing you're going to have to know is whether or not two matrices are equal. So two matrices are equal if they have the exact same order, which means they have the exact same rows and the exact same number of columns, and every single entry is equal. So for example, if I told you that matrix A was the matrix 1, 2, 3, and I told you that matrix B was the matrix 1, x plus 3, and 3y. And I asked you to solve to make these two matrices equal. All that means is that every single component must be equal. So obviously the ones in the first positions are the same. But that also means the 2 must be equal to the x plus 3. So you could write an equation and set 2 equal to x plus 3, solve for x, and in this problem the x is negative 1. And last, the 3 must be equal to the 3y. So I could again write an equation. And so for this problem, the y must be equal to 1. And so you have solved for the variables in order to make the two matrices equal. Next, we'll talk about adding and subtracting. So first thing is, in order to add or subtract, you have to add and subtract their corresponding entries, but you have to first make sure they're the same order, which means they're the same size. They have the same number of rows and the same number of columns. If they do not, then you cannot add them or subtract them. So if you have two matrices that are both m by n matrices, then you are just going to go through and add each of their corresponding items or subtract each of their corresponding items. Let's look at an example. So I have two examples here, and we're going to do addition first. So for example A, matrix A is a 2 by 2. It has 2 rows and 2 columns. Matrix B is a 2 by 2. So first verify that they have the same order. If they do, then your solution will also be 2 rows and 2 columns. So when you go to add, you're going to have to find 4 answers. So first you'll take row 1, column 1, negative 6, added to row 1, column 1, positive 2. Negative 6 plus 2 is 4. Then you'll go across and do 7 plus negative 4, and 2 plus negative 8, and 1/4 plus negative 4. I did a mixed number, and you have added the two matrices. If you wanted, you could program each matrix in your calculator, matrix A and matrix B, and use your calculator to add them, although it does take quite a bit of time to program them in the calculator. If you look at example 2, matrix A has 3 rows and 2 columns. Matrix B also has 3 rows and 2 columns. And because they are the same size, you're allowed to add them together. So your matrix is going to have 3 rows and 2 columns. And you literally just go through and add component to component. 1 plus 2, 4 plus 4, negative 2 plus negative 4, 6 plus 2, 7 plus negative 5, 0 plus negative 3. You have added two matrices together. Next, let's look at subtraction. Let's say that I asked you to take matrix C minus matrix D. Matrix C has 3 rows and 2 columns. Matrix D has 3 rows and 2 columns, so therefore this is allowed, and you will have 3 rows and 2 columns. And you just go component to component. Be careful to watch your signs. 1 minus negative 1, 2 minus negative 3, negative 3 minus 4, 0 minus 7, negative 4 minus 0, negative 2 minus 3. So most people, if they make an error, make it in the subtraction phase, and it's simply because they mess up their signs. So don't be afraid to use your calculator to check. Last example of subtraction. Matrix C is a 2-row and 2-column matrix. Matrix D is a 2-row and 1-column matrix. Because they do not have the same order or same size, you cannot do this problem. So this problem is impossible to do, and I would just say cannot be done. Next is scalar multiplication. Scalar multiplication is when we find the product of a number and a matrix. That's called scalar multiplication. So often they'll call the scalar letter K, they'll call the matrix a capital letter A, and then they'll denote it by saying Ka. So scalar multiplication is actually quite simple. In order to do scalar multiplication, you just have to multiply each entry by the number K. So for example, if matrix A is negative 4, 1, 0, 7, and I ask you to find 4A, all you have to do is multiply each component by 4. So it would turn into negative 16, 4, 0, 28. Done. You've done scalar multiplication. If I asked you to find negative 2A, same thing. You would take negative 2 times negative 4, negative 2 times 1, 0 times negative 2, 7 times negative 2. You have completed scalar multiplication. Very straightforward. Matrix multiplication is significantly more challenging. So you first have to pay attention to the order. So we'll say that matrix A is an M by N matrix, and that matrix B is an N by P matrix. Notice the N was repeated. That has to happen in order to do a scalar multiplication. So when you take a matrix A times a matrix B, you first have to decide what size it's going to be. The size is going to be M by P. Then you'll have to go through and you'll have to take the row 1 of matrix A times the column 1 of matrix B. And that's what this notation is trying to describe. I don't know if you'll understand that notation, so I'm going to walk you through a couple of examples. The key thing here, we can multiply two matrices only when the number of the columns in the first matrix is equal to the number of the rows in the second matrix. If that is not true, then you simply cannot multiply the matrices together. By the way, your calculator will also multiply matrices if you program them in by using the second matrix edit feature. Okay, so we're going to look at 3 different examples. We're going to start with matrix A times matrix B. So before I do anything, I'm going to check out the size of the matrix. Matrix A is size 2 rows and 3 columns. Matrix B is size 3 rows and 2 columns. So the first thing you want to verify is that the number of columns in matrix A and the number of rows in matrix B are the same. If that happens, then you are allowed to multiply the matrices together. If that does not happen, stop and say this is impossible, it cannot be done. So this is possible, we can do it. So then I have to decide what the size of my new matrix is. My new matrix is going to have 2 rows and 2 columns. So I will end up with 4 entries, 2 rows and 2 columns. Okay, now when I do this, I am first going to start with row 1 of matrix A, and I'm going to multiply that to column 1 of matrix B. So I'm going to take 2 times 0, 2 times 2, and negative 2 times negative 1, and then I will add those together. 2 plus 2 is 4, 2 plus 4 is 6, and 6 plus 2 is 8. So the first entry in my matrix is 8. And then I start that procedure over again. I'm now trying to figure out what's going to go in this location, and that location is row 1, column 2. So I will use row 1 from A and column 2 from B. And I will take and negative 2 times 3. Okay, so negative 6 and negative 14 make negative 20, and negative 8 makes negative 28. Okay, so now I'm looking for this location down here, which is in row 2, column 1. So I'm going to use row 2 from A and column 1 from B. And I'm going to do 1 times 0, 0 times 2, 4 times negative 1. And I will add those results together, and my third entry is negative 4. Last one. I'm looking for this location here, which is in row 2, column 2. So I'll use row 2, column 2. And I'll take 1 times negative 4, 0 times anything, 4 times 3. And I will add those together, and I'll get 8. And this is your answer if you multiply A times B. Now, where some people get frustrated is they think, oh, well, A times B and B times A are the same thing. They are not in matrix multiplication, so you have to be very careful. So let's look at that on the next slide. So this time, we're going to attempt to do B times A. So the first thing we're going to do is find the size of B. B has 3 rows and 2 columns. And then we're going to look at the size of A. A has 2 rows and 3 columns. And then you want to verify that the numbers in the middle are the same. And they are in this problem. So that means you are allowed to do matrix multiplication. It is possible. The size of your new matrix is going to have 3 rows and 3 columns. So you're going to have 9 entries total. So let's do that and see what we get here. All right, so we need 9 entries total. Okay, and remember, B comes first, so we have to use its row. So this entry that we're working on right now is in row 1, column 1. So we'll use row 1, column 1. We'll do 0 times 2, negative 4 times 1. Next entry is row 1, column 2. Row 1, column 2. So we'll do 0 times 2, negative 4 times 0. Next entry is row 1, column 3. Row 1, column 3. So we'll do 0 times negative 2 and negative 4 times 4. Okay, and then we'll add those together here in a minute. Now let's work on the next one. This one is row 2, column 1. Row 2, column 1. So we'll do 2 times 2, negative 7 times 1. Next entry, row 2, column 2. Row 2, column 2. 2 times 2, negative 7 times 0. Last entry is row 2, column 3. Row 2, column 3. So we'll do 2 times negative 2 and negative 7 times 4. Okay, last row. Row 3, column 1. Row 3, column 1. Negative 1 times 2, 3 times 1. Row 3, column 2. Row 3, column 2. Negative 1 times 2, 3 times 0. Row 3, column 3. Row 3, column 3. Negative 1 times negative 2, 3 times 4. Okay, and then to finish it off, you would want to add all of the entries together. So 0 minus 4, 0 plus 0, 0 minus 16, 4 minus 7, 4 plus 0, negative 4 plus 28, negative 2 plus 3, negative 2 plus 0, and 2 plus 12. And that is your solution. Okay, last one, just for good measure, I want to show you A times C. Matrix A has 2 rows and 3 columns. Matrix C has 2 rows and 2 columns. Always check that first. Notice that the numbers in the middle do not answer. You are not allowed to do matrix multiplication on this. This cannot be done. Don't even try. If you do try it in your calculator, you'll get an error. I believe it will say dimension error. Last thing I wanted to show you was sometimes they'll throw some story problems your way. Don't panic. It's just the same thing. They just want you to write your own matrix. So let's look at this situation. Dalton's Dairy produces no-fat ice cream and frozen yogurt. The following table shows the number of gallons of each product that are sold at the dairy's 3 retail outlets 1 week. On each gallon of no-fat ice cream, the dairy's profit is $4. And on each gallon of frozen yogurt, it is $3. Use matrices to find the total profit on these items at each store for the given week. So a lot of people panic about that. You don't need to panic about that. All we need to do is figure out the total amount of ice cream sold and multiply that times 4. We need to find the total amount of frozen yogurt sold, multiply that times 3, add the results together, and that'll give you your total profit. Where people get confused is that they have asked you to do it with a matrix. So let me show you how you would set this up with a matrix. Let's scoot this up. So if you were going to do a matrix, the first thing you would want to do is set up the sales in a matrix. So notice store 1 sold 100 gallons of ice cream and 160 gallons of yogurt. Store 2, 80 gallons of ice cream, 120 gallons of yogurt. Store 3, 120 gallons of ice cream, 100 gallons of yogurt. So see how I've set this up in a matrix? My matrix has 2 rows and 3 columns. Then you need to take the price. We make $4 a gallon on ice cream and $3 a gallon on yogurt. And so we have 1 row and 2 columns. And so then you need to take the price, which is a 1 by 2, times the distribution, which is a 2 by 3, and that will get you your total profit. Okay, so if we did that, we can do that on, we can scoot this over. So we would just take our 4 by 3 times our other matrix, okay, our answer matrix is going to have 1 row and 3 columns. And this will tell us profit by store. So we will first take row 1 times column 1. So we would do 4 times 100 and 3 times 160. Add those together. Then we would take row 1 times column 2, 4 times 80, and 3 times 120, and add those together. And then row 1 times column 3, 4 times 120, and 3 times 100. And so this matrix would represent profit by store. Okay, last but not least, sometimes we'll have systems of equations and they don't want to write it as an augmented matrix like we did in the last class. They will write it as what they call a matrix equation. So when you do this, the left-hand side of the system of equations will become 2 matrices. You'll take all of the coefficients, 3, 1, -1, 5, 0, 1, 1, -2, -3, and write that as a matrix. Then you'll take the variables that are being used, x, y, z, and write that as a secondary matrix. And last, you'll take the solutions, 11, 9, and 3, and write that as the solution matrix. If you wanted, rather than solving with row reduction and augmented matrices, you could solve by using an inverse matrix, where you take the inverse of this matrix times the solution matrix. I'm not going to require you to do that, but if you do want to find the inverse button, look for the key on your calculator that looks like an x to the -1. That's the easiest way to find the inverse of a matrix. Okay, so that is it for this section. So get started on your homework. Remember, you need to complete section 6.3. Try not to use the shortcut calculator technique because remember, you need to show your work on your test. You have section 6.4 and you also have a chapter 6 quiz. I have loaded the review onto D2L if you would like to see that. And Tuesday we will do review in class. And the test will be Thursday. Okay, have a great weekend, everybody.